We're going to continue our studies on gases and learn about some of the things that can affect them, and also kind of a handy way to set up problems and keep track of numbers regarding gases, and they're called IFE tables. So just a quick review, we talked last time about gas pressure. So what is that again? Remember, a gas gets its pressure from all those collisions between the particles, either them hitting each other or them hitting off some kind of surface. It could be the walls of its container or whatever it's in. And that is what is creating pressure in gas. And remember, of course, that it can change, right? If you're at the top of the mountain, you've got less gas above you, so you'd have less gas pressure. If you're at the bottom of a canyon, you'd have more. Different weather patterns can change the pressure of a gas, like that would be air. But we've already learned about that, so today we're going to learn about something different. What if we've got one place, weather is constant, we're not changing our altitude, there are still things that can happen to change the pressure of a gas. And so we're going to look at those things. The three main variables that can affect a gas's pressure would be the amount of gas, the volume of gas, and the temperature of gas. And we're going to go through each one of those individually. So the amount of gas. Basically, if you take a container and so like here's a container and here's a bicycle pump hook up to it, right? So here's some gas particles, they're zooming around there. And let's say I take my bicycle pump and I pump some more air into here. Well, now all of a sudden I've got way more particles in here. They're zooming around still, and they're hitting each other a lot more, and there's more particles to hit the sides of the container. And as we know, since pressure comes from particle collisions, this is going to increase the pressure in the container, okay? If I were to keep doing this, eventually I could explode the container, kind of like popping a balloon, but we're not going to get into the specifics on that. But understand that if you increase the amount of gas, then you will increase the pressure because we've got more collisions happening. Let's talk about the volume of gas. If you have a gas and you squish it, that's going to give it more pressure. So here's an example. Here's some gas zooming around, and then I take this thing and I push down on it. And notice how much closer together these particles are. So they're going to hit each other a lot more, and they're going to bounce off the walls a lot faster because there's less room to be in. And so this is going to increase the pressure. On the flip side, if I were to go this way, if I were to start here and pull this up and give it bigger room, oh, now my gas can spread out. It's got more room. It's still going to bump into things, but less frequently. So this will decrease the pressure in this container. The last variable is temperature. So hopefully you guys remember back from kinetic theory that when you increase something's temperature, you make it move more. Okay, and so this is what we're seeing right here. Here's a container. We heat it up. That heat is going to make this gas move more, and when it moves more, it's going to hit other gas particles, and it's going to hit the sides of the container more, which would increase its pressure. One thing to know is, let's say you've got a container that isn't a super solid, steady shape. You've got a container that's like flexible, maybe like a balloon or something. If you take the gas in there and you heat it up, it's obviously going to want to move around and spread out more. And because it's in a flexible container, it can spread out more. And so if you've got a flexible container, when you heat something up, when you heat a gas up, its volume is going to increase here. Okay. And if you've got something where the volume can't increase, then we're going to see our pressure go up. So, we're going to use these things called IFE tables, and they're a way to kind of keep track of your numbers when you're solving a problem. We're going to use this for gas laws, and we're going to use it again for a different thing later in the year. So the I stands for initial, and the F stands for final, and the E stands for effect. Okay, so here are the 5 steps. I highly recommend that you write down these 5 steps. Step 1, write down the problem tells you. Step 2, place an X in the square for what you're solving for. Step 3, cross off anything left over. Step 4, determine the effect and draw an up or down arrow. And step 5, do the math and solve. Okay, so if you didn't get that, pause the video and then push play when you're done so you have those down. Here's what an IFE table looks like. It's got I, F, and E along the left side, initial, final, effect. And then across the top here, these are our gas variables. P stands for pressure, V stands for volume, T stands for temperature, and N in chemistry stands for the amount of a gas. So N is amount. Okay, that's kind of the only tricky one that it doesn't make sense by just looking at it right away. Pressure, volume, temperature, amount. Okay, so here's like the blank table that we would set up before doing a problem. And then I'm going to show you an example and we're going to work through how you fill one of these out. Okay, so let's say here's an example problem that you could get and have to do. A gas occupies 100 milliliters of space when it's at 25 degrees Celsius. If its temperature is raised to 50 degrees Celsius, what will its volume be? Okay, I'm going to go back to my 5 steps. I'm going to follow them in order. So step number 1 is write down what the problem tells me. Okay, so I'm reading through. It says a gas occupies 150 milliliters of space. This is going to be a volume. I can tell because milliliters, and it's something occupying space, which is exactly what volume is. So I'm going to put 150 right here under the I for initial. And since it's a volume, I'm going to put it where the I and the V come together. And then I get 2 temperatures. I get 25 degrees Celsius and 50 degrees Celsius. And you might think that I would just go plug in 25 and go plug in 50. Well, one thing is when we're doing problem with gases, we want to use Kelvin, because remember, Kelvin is a direct measurement of the kinetic energy something has. And so as it turns out, this is a time when we use Kelvin. And so over here are my Kelvin calculations. And just to get to degrees to Kelvin, you take your degrees Celsius and you add 273. So I take 25 plus 273 and I get 298 as my initial temperature. So I put that in the I column, in the I row, excuse me, and right here in the T column. I do the same thing with 50. 50 plus 273 equals 323, and so that goes in my final. Okay, so that's the 3 pieces of information that this problem gave me. It gave me an initial volume, it gave me an initial temperature, and a final temperature. Step 2, place an X in the square for what you're solving for. Well, the question asks, what will its volume be? So I'm looking for final volume. So I'm going to put an X right there. Step 3, cross off anything left over. This question had nothing to do with pressure, and this question didn't mention anything about amount of gas. So I'm going to put a big X through there. I don't have to worry about those columns. In a different problem, one of those might be mentioned, and so you might not be crossing off that column. But for today, for right now, we're not worrying about those. Step 4, determine the effect and draw an up or down arrow. So if I'm looking, if I start at 298 and I go up to 323, or if I start at 25 and I go up to 50, is my temperature going up or down? Well, it's increasing, so it's going up. So I would draw an up arrow right here. Okay, so I would have to fill that in. Obviously, it wouldn't already be filled in for you. And then I have to think, okay, what does an increase in temperature do to my volume? And if you remember from a couple slides ago, we talked about if you increase the temperature of a thing, of a gas, it's going to increase its volume. Okay, so I would put an up arrow in the volume. That is the effect. If I raise the temperature, I raise the volume. Okay, so in order to solve this problem, I'm going to end up setting up a ratio here, okay? I'm basically going to put my volume on one side and my temperature on the other, okay? Now, what I put on top and what I put on the bottom matters. Since I'm expecting an increase in volume, I want my bigger number to be the numerator, which is on top of my ratio. And since I'm expecting it to get bigger, that means that this final value, this X value, should be larger. And so I'm going to put that on top. I'm going to put that as the numerator, and I'm going to put 150 on the bottom. And then for my 2 temperature values, again, because it increased, I'm going to put the bigger one on top. So 323 goes on top and 298 goes on the bottom. So in order to solve this, I'm just following like math rules here. But you're going to cross multiply. So you're going to do 150 times 323 and divide that by 298. It matters how you enter this into your calculator. You need to make sure that you do 150 times 323 first and push the equals button, and then divide that big old number by 298, and then push the equal button, and then your calculator will tell you 162.58, or we could round that off to 162.6. And our units there, because we're talking volume, since we got milliliters, our units would be milliliters. So that is the basics on how you can use an IFE table to set up a problem and help you kind of keep track of your numbers and help you figure out if things are going to increase or decrease. We're going to do a whole bunch of practice with this in class, so don't worry. I just want to make sure that you have copied down how to do one, the steps, how to fill one in. Make sure you've written down this example because this will be really helpful to you when you're going to solve some of these on your own in class.